Welcome to the Deep Dive. Today we are embarking on, well, quite a journey actually, into one of the cosmos's most profound and perplexing enigmas, black holes. We've gathered, a rich stack of sources, and we're going to pull out the key insights on these cosmic giants. Everything from their dramatic birth to their really mind-bending properties. Our mission really is to make sure you walk away well-informed about these fascinating objects.
Absolutely, and it's fascinating because these seemingly empty, dark patches of space, they hide this immense power. They really challenge our basic understanding of reality. We're aiming to pull back the curtain a bit on how something that looks like, nothing, a void, can actually hold such incredible might and fundamentally warp the universe around it.
Yeah, just imagine for a moment, the vast, silent expanse of the cosmos. Billions of shimmering galaxies, countless stars. It stretches out across distances we can barely comprehend. And then, right in the middle of all that light, a region of perfect darkness. No stars visible? But if you look closely, maybe you'd see this tiny, subtle distortion of light from way behind it. It hints that something unbelievably powerful is lurking there.
That initial impression, that deep darkness, it really sets the stage for why there's such enduring mysteries, these perplexing enigmas in the vast canvas, as you said.
So the big question then, how does something like that even come to exist? What's the origin story, the dramatic beginning?
Well, it all starts with a star. But not just any star, We're talking about a real Titan star, far, far more massive than our own sun. For billions of years, these things are like cosmic furnaces, right? They're fusing elements in their core, creating this outward pressure. And that pressure is in this delicate balance, constantly fighting the inward pull of the star's own huge gravity.
The constant battle.
Exactly. But, like all furnaces, eventually the fuel runs out. That outward push just fades. And gravity, it's relentless. It finally wins. The star's core just collapses inwards under its own colossal weight, compressing all that matter down to a density that's just, it's unimaginable.
And that collapse isn't quiet, is it? It triggers something enormous.
Oh, absolutely. It triggers one of the universe's most spectacular events, a supernova. The star basically explodes.
Right. Briefly outshining entire galaxies, I've read.
That's right. Just immense energy released. But in the aftermath, from what's left of that collapsed core, that's where the black hole is born. An incredible cosmic transformation, really.
So once it's formed, this gravitational behemoth, it has these unique features, these boundaries, unlike anything else. What are they? What makes them so, frankly, terrifying?
Okay, so the most defining feature has to be the boundary itself, the event horizon.
The point of no return.
Precisely. Think of it like an invisible line in space, or maybe a cosmic threshold. Once you cross it, the gravitational pull is so overwhelming that escape is just impossible. Nothing gets back out. Not even light, the fastest thing in the universe.
I like the analogy of a cosmic waterfall. The event horizon is the absolute edge. Anything that goes over, swept away forever.
That's a great way to picture it, yeah. And it also means, for someone watching from far away, time itself would seem to stretch out infinitely for anything falling towards that edge. Really bizarre stuff.
And then, deeper inside.
Right. If you could somehow look past the event horizon, at the very core, our theories predict the singularity.
The singularity?
Yeah, a theoretical point of infinite density.
Yeah.
All the mass of that original giant star crushed into an infinitesimally small space. And this is where things get really weird, because our current understanding of physics, like general relativity, it just breaks down.
Can't describe it anymore.
Exactly. The laws of space-time as we know them are stretched beyond comprehension. These infinities tell us our theories are incomplete at those extremes.
Wow. And this intense gravity, it doesn't just pull things in, right? It affects space-time itself.
Yes, profoundly. It's not just a force pulling things, it's a warping of the very fabric of space-time. Objects nearby get yanked into these incredible tight orbits, and those that get too close, they experience extreme tidal forces. They get stretched and torn apart.
That's the spaghettification I've heard about.
That's the one. A chillingly accurate term, actually. The gravity difference between, say, your head and your feet becomes so extreme over such a short distance that you literally get stretched out like spaghetti.
Yikes.
And interestingly, that effect is actually much stronger, much more severe for smaller stellar mass black holes. The tidal forces are more intense closer to the event horizon.
Spaghettification. Yeah, that really brings home the immense power. So, okay, let's talk scale. How do we even begin to wrap our heads around how big, or maybe how small these things are? We go from a star collapsing to infinite density. How does that compare?
Right, it's tricky. Let's try some perspective. Think about Earth.
Right.
Then think about our sun. Huge, right? could fit over 1 million Earths inside it.
Okay.
Yet, a stellar mass black hole, one born from a star maybe a few times the mass of our sun, or even one with the mass of our sun,
Yeah.
it can be shockingly compact.
How compact?
Its event horizon, that point of no return, might only be a few kilometers wide, literally smaller than a city. All that mass in such a tiny region.
That's incredible. But then there's the other kind.
Then you have the supermassive black holes. These are the true giants. Millions, or sometimes even billions, of times the mass of our sun. We find them lurking at the centers of most big galaxies, including our own Milky Way. We have Sagittarius A right at the heart.
And those must be enormous.
Oh yeah. Their event horizons aren't measured in kilometers, but can span light years, vast distances. But what's really fascinating about these supermassive ones is they're not just sitting there. They seem to play a role in how galaxies evolve. They're like engines of galactic evolution.
How so?
Well, their immense gravity and the material falling into them can create these powerful jets of energy, and this feedback can actually regulate star formation across the entire galaxy. It shapes how the galaxy grows and changes over cosmic time.
Wow, so from city size to light years across. Born from the same basic idea but playing such different roles.
Yeah.
Okay, let's go back to the light thing. How can we really understand why nothing escapes? Not even light.
Analogies help here. One common one is to imagine space-time as like a flexible rubber sheet, stretched out flat.
Okay.
A normal star or planet makes a little dip in the sheet, but a black hole, it creates an incredibly deep well, infinitely deep, theoretically. So anything that rolls into that well, even a beam of light moving incredibly fast, it just can't climb back out. It's like rolling a marble into a bottomless pit. It's trapped.
Yeah, that makes sense.
Another way to think about it is like a powerful river, a cosmic river flowing incredibly fast.
Space-time is a river.
Yeah. And the event horizon is the point where the current of space-time itself starts flowing faster than the speed of light, pulling everything inwards. So even light, paddling as fast as it can at its cosmic speed limit, is still swept downstream. It just can't swim fast enough against that overwhelming flow of space itself into the black hole.
Forever trapped within its grasp.
Oh.
Okay, so we've taken quite a deep dive here. Black holes.
Yeah.
These cosmic giants that just defy our intuition, don't they?
I mean,
They challenge the very fabric of reality, stretch our physics.
They really do. They are, in a sense, the ultimate cosmic prisons, holding secrets that honestly may forever remain just beyond our reach. And yet, as we touched upon, there are also these vital engines shaping the galaxies we live in. It's quite a paradox.
Absolutely. And despite all the incredible things we've learned, the core mystery, the profound puzzle, it remains. You know, what truly lies beyond that event horizon? What secrets does that singularity actually hold? That point where all our known laws of physics just stop. These are the kinds of questions that continue to inspire us, to challenge us, and really ignite the human imagination. They keep beckoning us to explore the endless wonders of our universe. Thank you for joining us on this deep dive. Keep exploring.